Hi there, and welcome to Ideal Gas Laws with Professor Todd. Today, I'd like to speak to you about an important topic in the subject of chemistry, the ideal gas laws. Now, first, let's start with the equation. It's very famous and goes by the acronym of PIVNERT. Let me just get my eraser. And so today, what we'll do is we'll go through this equation, and then I'll walk you through a problem to show you how the ideal gas laws are solved. So first, let's start with the variables. Over here, we have our variable is pressure, and pressure is measured in torr or pascals or kilopascals. Next, we have volume. Volume is measured usually in liters. N would be our number of moles. And R is our gas law constant, which I will provide to you as I am demonstrating a problem. And then we have T, which is found in Kelvin, and temperature. Temperature can be converted from Celsius to Kelvin by adding 273 degrees. Now, this equation is part of the Virginia Standards of Learning number 5, and it involves pressure, temperature, and volume changes. So let's go ahead and get started with a problem. I will read this problem to you, and we'll go ahead and we'll solve it together. So here it goes. As I read the problem, I will write down the pertinent information which will help us to solve it. So the problem goes as this. The pressure on a gas is 150 kilopascals. The temperature is standard temperature, and the volume is 250 milliliters. How many moles of this gas do we have? Okay, so let's start with our gas law constant, which is R. R equals 8.31 kilopascals times liters divided by moles times Kelvin. Okay, so this problem states the pressure on a gas is 150 kilopascals. So what I always recommend is let's put our variables on the board. Pressure equals P equals 150 kPa. Now, the next portion of information we get is the temperature is standard temperature, which is standard temperature is always going to be 273 Kelvin. So T equals 273 Kelvin. Okay, and then the volume is 250 milliliters. So volume equals 250 mLs, which we'll have to convert that to liters since liters is in our constant. So we'll take that, and what we'll do is, since 1,000, since 1 liter equals 1,000 milliliters, what we'll do is we'll just go over 3 spots, and we will have 0.25 liters. Okay, and then now what we want to know, as I stated before, are the moles. Moles are unitless. So now we have all our information. We can go ahead and we can solve for moles. What I recommend doing first is to isolate the variable n. So in order to do that, we'll figure out what can we do to get this by itself? And I may have to erase this just so I can have some more room. So what we'll do is we will isolate, in order to isolate the n, we need to divide by RT. So what we get is n equals PV over RT. So now what we could do is what I like to call plug and chug. So we said that our pressure is 150 kilopascals. So we'll put that in for P. Our volume, we said, was 0.25 liters. Put that in. And then our gas law constant is 8.31 kilopascals times liters divided by moles Kelvin. And then our temperature, we said, was 273 Kelvin. Okay, so now all you really have to do is plug those numbers in your calculator and you come up with the answer. And our answer is n equals 0.0165 moles. So there you have it, folks. As you can see, science, chemistry is a lot of fun. And when you know what you're doing, it's really simple. So I just encourage you to keep at it and do your best. And thanks for joining me today. Bye.